Bismillahirrahmanirrahim. So the topic which we are going to study is the testing of hypothesis for two sample independent t-test. So इसके अंदर हमारे पास क्या है कि अगर हम डिजाइन ऑफ एक्सपेरिमेंट के पर्सपेक्टिव से देखें तो हमारे पास जो आउटपुट है दैट मीन आउटकम y वो हमारे पास एक ही है और एज वेल एज जो हमारे पास x है दैट इज अ सिंगल फैक्टर वो भी एक ही है. सो फैक्टर इज आल्सो वन. ओके और हमारे पास आउटकम तो एक है ही है और वो मेजरेबल है, मीन वो क्वांटिफाएबल है. सो फैक्टर लाइक फॉर एग्जांपल अगर हम कहें कि हमारे पास एक फैक्टर है जी मशीन एंड वी वांट टू कंपेयर द टू मशीन्स with respect to their performance. Okay, so that is y, right? So machine A and machine B. So factor only one that is a machine, but there is a two types of machine जिनको हम design of experiment language पे कह देते हैं. These are the two levels. Okay, so machine A versus machine B. We want to compare it whether on average machine A is equally good with respect with machine B or not equal. Or machine A performing better than machine B, right? So that is the two sample independent t-test when both the samples are independent and we want to compare with respect to average value. Then we can apply the we can use the testing of hypothesis for two sample independent test. Okay, so here we have 4 different types of tests. If you want to compare the difference of the means, the first two were with respect to when the population. The first one is we want to compare the difference of means when the population standard deviation of the both the variables are given, and the second one is when the we want to test the difference of mean when the both the population standard deviation are unknown and the sample size is greater than 30, or you can say the large sample size. In these two cases we will apply the z test. Okay, and as you may remember in the last lecture we discussed that so what was the z test statistics when the standard deviation was given, then we can apply x1 bar minus x2 bar minus mu1 minus mu2, right, and divided by we have sigma 1 square over n1 plus sigma 2 square over n2. So this was the statistics where the population standard deviation was given, and when the population standard deviation was not given or unknown, so we will use instead of sigma 1 and sigma 2 we will use capital S1 square capital S2 square. That is the sample standard deviation, but these standard deviation are the bias standard deviation. But like जिस मैंने को पहले भी बताया था कि practically speaking Z distribution जो है वो बहुत rarely इस्तेमाल हो रही होती है, ठीक है. So इसलिए हम इसको जो है वो यूज नहीं कर रहे, मीन हम इसको Minitab जो है वो उसके जरिए हम अटेम्प्ट नहीं कर रहे. हम फोकस किसके ऊपर कर रहे हैं, हमने जब डिफरेंस ऑफ मीन को जो है वो अप्लाई करना, मीन टेस्ट करना when the population standard deviation are unknown. Okay, so you can ignore this part, means sample size less than 30 है या नहीं, still if the population standard deviation are unknown, so you can apply the t-test, right? So that means we are going to talk about these two tests. Difference of mean when the population standard deviation are unknown, but the test will be different if the variances are equal, and test would be another one that when the variances are unequal. So which means before applying the two sample independent t-test, so which means these two are talking about two sample independent t-test we are talking about. Okay, but we will say we are going to apply two sample independent t-test with equal variance, or we are going to apply two sample t-test with unequal variance depending upon the situation. So that means how we will identify that one, we can check the requirement. Okay, so as you know that for the t distribution or for the chi-square distribution or for the f distribution, the first thing which we have to identify whether the data is following the normal distribution or not. Okay, so first of all we are going to check the normality of the data, and the second thing which we are going to discuss that whether the variance of the two groups, the two independent groups which we want to compare with respect to their averages, whether the variance of the two groups are equal or not equal. Okay, so to do that, we theoretically discuss the F test. Okay, so whenever you are going to compare the two population variances, we can use F test, but F test can be applied, as we know that we have discussed in the previous lecture, that for the F test the data must be normal. So that means if you want to compare the two groups and you want to check whether the variance of the two groups are equal or not equal, mean that is indicating the homogeneity and the heterogeneity. So homogeneity mean when the both the population variances are equal. Heterogeneity mean when the both the population variances are unequal. So if the homogeneity is there, mean to check the homogeneity, whether it is homogeneity or heterogeneity, we can apply the F test, whether the both the population variances are equal or not equal. But make sure, so F test can be applied only when the data is normally distributed. But if data is not normally distributed, then we can apply Levene's test. So we will also discuss this test as well. So basically what we will do, I will use the Minitab to apply all these four tests, right? But first of all, we will go step by step the main idea is we want to apply two sample independent t-test, because the two sample independent t-test, as we know that, can be used to check the differences of the two population. Is the two population means are equal or not equal? Okay, so to do that we can apply the two sample independent t-test. So but for two sample independent t-test, there is a two condition. First of all, we must check whether the data is follow the normal distribution or not, and the second thing is the population variance of the two groups are equal or not equal. Okay, so let me start with the Minitab file. And the problem is, the example which I am going to discuss is with the two sample independent t-test, is that I am taking the example of the hospital comparison data. Okay, so there is a two hospitals. Okay, and we have collected the data from the 20 patients, right? And the hospitals, I am saying A and B. So one column is indicating the hospitals. Okay, the one column is indicating the hospital, right? That is A type hospital and B type hospital. Another one is the rating, right? So this is the rating. So I want to compare whether the two types of hospitals are equal or not equal. Okay, or with respect to on average. But the first condition is, as we know that, to check the normality of the data. So that means we will check is the rating variable, which is a continuous variable, which is y in this case, as well as x. What is the x, or you can say factor? That is a hospital, and hospital has two levels. One is A type hospital and another is a B type. So the first condition is we need to check the normality of the rating. So how we can do that? We will go to stat, basic statistics, and normality test. So if I click on the normality test, okay, rating. So as we have discussed in the previous video as well, like we can apply either Anderson-Darling test, okay, or either RJ test, or either KS test, mean Kolmogorov test, okay, to check the normality test. So I'm applying AD test, so Anderson-Darling test, press OK. Okay, similarly, if you can see that, like this is the ideal normal probability plot, which is indicating with the red line, okay, and the blue dots, if they are lying exactly on the line, so then we will say the data is normally distributed. But as I earlier told you that this is a descriptive approach, so it might be possible we cannot make the right decision. So in order to do the right decision, so we can use this p-value. Okay, so we know that how we can interpret this one, like if the p-value is greater than or equal to the alpha value, we will say except h naught, and this is a pre-decided value. So right now p-value is 0.719, greater than or equal to the, what is the alpha value, which is 0.05, if we are assuming that the alpha is 0.05%. Okay, so this condition is true, mean the p-value is greater than the pre-decided alpha value. So we will say except h naught. And what was the h naught? H naught is, that is, data is follow the normal distribution, right? So we have seen that the data is following the normal distribution. That is, the first condition is fulfilled. Okay, the requirement of the two sample independent t-test is data is following the normal distribution. Now we need to check whether the variances of the two groups are equal or not equal. So in order to do that, how we can test whether the two groups are homogeneity or not or heterogeneity. Okay, so the equality of variance we can test with two way in Minitab. The first way is you can use stat, basic statistics, and two variances in order to check the equality of the variance. So if I click over here, okay, so they are asking is the data is in a single column or in a two columns. So right now we have entered the data in a single column. So we will send the rating values in a samples, and in sample ID we will send the hospital. Okay, and then if I go to the options, right, so whether we want to test the ratio of the standard deviation or the ratio of variance, so I'm using ratio of variances, right? So 95% confidence mean alpha is equal to 1, and the hypothesized ratio means, as we know that, so in F test we will write down H naught sigma 1 square sigma 2 square is equal to 1, right? Whereas in alternative hypothesis, the ratio of the variances is not equal to 1. Okay, so this is the two-tailed test. So right now it's a not equal to 1 and equal to 1, right? Ratio is not equal to the hypothesized ratio, and the hypothesized ratio is equal to 1, that is this one. So it might be other than 1, mean we are saying the ratio of the variance equal to 5 or 6. So by the way, in this particular case, we want to test whether the variances are equal or not equal. So that's why we are using 1. Okay. So another thing is, if you can see that, so they have mentioned that is use test and confidence interval based on normal distribution. So as we have already find out that the data is following the normal distribution, so that's why we will need to check this one. So if I'm going to check this one, so you will find out that the Minitab will apply the F test. If I will uncheck this one, so Minitab will apply the Levene's test. Okay, so I'm going right now, I'm going to check this one, press OK, because why I'm checking this one, because the data was the normally distributed. Or if I want to plot some graph, so I'm using by default summary, and then simply press OK. Okay, now if you can see that, like, the test is the ratio of the variances. Okay, so they apply the ratio of the standard deviation as well as the ratio of variance. So but ratio of variances, and we have seen that this is null and alternative hypothesis, and the p-value is equal to 0.076, because we use 95% confidence, that means alpha is equal to 5%. Okay, whereas the p-value is 0.076, and this 0.076 is greater than or equal to 5%. So that means this condition is true. So we will say except H naught. And what was that? That is the ratio of the variances equal to 1. That means both the variances are equal. So that means we will say this is a homogeneous, right? Both the population has the equal variances, right? Okay, so let me apply just by assuming the data is not normally distributed, right? Right now we applied the data is normally distribution. That's why they have given us the F test answer. So let me apply again the two variances, the ratio of the two variances. But right now I'm assuming the data is not normal. Although it's normal, but just to check is the results are different or not different. So press OK, press OK. So instead of they are giving us the F test results, So right now they have given us the Lebanese test. So you will use Lebanese test. So even they are also giving us the bond test results like in a chi-square test. So you can use both, but the better way is use the Lebanese test. Okay. So again, Lebanese test is also telling us that both the population variances are equal. Okay. So either you are applying the parametric or the non-parametric test. So both are giving us that both the population variances are equal. But right now, in this particular case, because the actually data was normally distributed, so that's why we have to apply the F distribution. Okay. So okay, and there is another way in Minitab to check whether the variances are equal or not equal. So what was that way? That is, you can go to stat ANOVA, okay, and then test for equal variances. So if I click over here and our data is in a single column, so in response we will send rating, in factors we will send hospitals, and then we will click on options. Okay, confidence interval is 95, that means alpha is 5%. Again, so they are giving us, is it a normally distributed or non-normal? If the data was non-normal, we will uncheck, but right now this is a normally distributed. So we will check this one, press OK, and then press OK. Okay, again, now you can see that this is the F test, the same result we are getting. Okay, I hope you have आपको clear हो गया कि how we can check the equality of the variances. So हमने जो है वो that normality of the data भी check out कर ली है, as well as we have checked the equality of the variances. Okay, so now we can apply the two sample independent t-test because both the assumptions are satisfied. One is data is following the normal distribution, another one is the variances are equal. If variances was unequal, then we can again apply the two sample independent t-test, but that was a Welch approximation. Okay, so by the way, how we can do that, how we can apply the two sample independent t-test, we will go to stat, basic statistics, two sample t. So if I click over here, okay, the data was in a single column, and if I click on samples, we can send rating, and in sample ID we can send hospitals, and then options. Because it's a two-tailed test, so that's why I am writing down that the alternative hypothesis is not equal. Okay, and the difference is 0, mean mu1 minus mu2 is equal to 0. Okay, in bottom they are saying whether we should assume equal variance or not equal. If I will uncheck this one, that means it is assuming the variances are unequal. That means it is applying Welch approximation. But we have seen that through F test as well as Lebanese test that both the population variances are equal. So that's why we will click over here that both the population variances are equal. So that means we are saying that both the population has in the homogeneity condition is fulfilled. So press OK. And then if you want to apply some graphs, so let's say box plot, press OK and press OK. So this is first thing they have given us, that is the descriptive analysis. Okay, and then they have given us the confidence interval, okay, on the difference of mean, the hypothesis test, and p-value. Okay, so right now what they are showing us that the p-value is 0.000. So that means this p-value is less than alpha value. And what was that? That is 5%. Okay, is less than. Okay, so which means we will reject H naught. Okay, sorry, yes, we will reject H naught. So that means both the hospitals having not same rating. So it might be possible one of the hospital has greater rating compared to the another hospital. Okay, so specifically if we are saying because we have considered the two-tail test, so that means we cannot say one is better, another is not better. But right now we can conclude that both the hospitals have not equal on average rating. Okay, सो ये चीज जो है वो हम डिस्क्रिप्टिव एनालिसिस से भी देख सकते हैं. डिस्क्रिप्टिव एनालिसिस में अगर हम जाएं ऊपर, तो हमें वो चीज़ यहाँ पे नज़र भी आ रही है कि आपके पास जो मीन ऑफ द हॉस्पिटल ए है वो कितना है 80 एंड मीन ऑफ द हॉस्पिटल बी कितना आ रहा है 59। और इनका अगर हम स्टैंडर्ड डेविएशन भी देखें तो ये स्टैंडर्ड डेविएशन भी कम आ रहा है। सो इट मीन हॉस्पिटल की जो रेटिंग है वो कंपेयर टू बी बेटर आ रही है। ओके, so hospital rating is better than hospital, sorry, hospital A is better than hospital B, right? You can also test with respect to one tail test, but right now it's a two tail. So even box plot से भी हमें indicate हो रहा है कि on average hospital A की जो rating है वो better है। आई होप कि आप लोगों को क्लियर हो गया कि ऑल दीज 4 टेस्ट जो भी हमने डिस्कस किए कि अगर तो आपके पास वेरिएंस इक्वल आ जाए, सो वेरिएंस की इक्वालिटी हमने कैसे चेक करनी है, एफ टेस्ट के जरिए अगर डेटा नॉर्मली डिस्ट्रीब्यूटेड है, और अगर आपके पास डेटा नॉर्मली डिस्ट्रीब्यूटेड नहीं है तो लेवनीज टेस्ट के जरिए। सो वंस वी चेक कि डेटा अगर नॉर्मली डिस्ट्रीब्यूटेड है प्लस इक्वली वेरिएंसेस आर इक्वल है, तो देन वी विल अप्लाई इक्वल वेरिएंस। ओके, अगर वेरिएंसेस आर अनइक्वल आ जाते हैं यहाँ पे तो फिर हम अनइक्वल वाला अप्लाई करते जो कि वेल्च अप्रोक्सीमेशन है। ठीक है जी, आई होप यहाँ तक। Okay, now we are moving towards the next test, that is the peer T test, right? So what was the difference in two sample independent T test as well as in a peer T test? Normally you can say in a peer T test, we are assuming that they have some dependencies, okay? Whereas in two sample test, that is the independent samples. So independency means like we can take the example of the maintenance. Like for example, we have taken the data from a machine before maintenance, and then we have taken the data after the maintenance to check whether the maintenance has some significant effect or not, मीन कि हमारी जो मेंटेनेंस करने का हमें कोई फायदा भी हुआ है या नहीं हुआ। ठीक है, सो अगर हमने पेयर्ड की शक्ल में अप्लाई करना है टू चेक ऑन एवरेज, ठीक है, सो वहां पे हम पेयर टी टेस्ट अप्लाई करते हैं। सो यहाँ पे भी हम मीन को ही कंपेयर कर रहे होते हैं, टू सैंपल ग्रुप्स को ही, ठीक है, बट इसको हम दो तरीकों से अप्लाई कर सकते हैं, क्योंकि यहाँ पे जो एच नॉट है वो हमारे पास क्या हो जाता है म्यू डेल्टा, और यू कैन से म्यू डी इज इक्वल टू 0, और H1 हमारे पास क्या आ जाता है म्यू डी इज नॉट इक्वल इफ वी आर कंसिडरिंग टू टेल, if we are considering one tail, so instead of not equal greater than or less than आ जाएगा। whereas mu d का मतलब क्या है, that is mu1 minus mu2, okay, so that mean that is a difference को indicate कर रहा है। ओके, और सो बेसिकली हम डी कैसे निकालते हैं कि वो जो दो ग्रुप्स होते हैं एक्स और वाई, हम इस डी को इनके डिफरेंस से निकाल लेते हैं, दैट इज एक्स माइनस वाई करते हुए। सो दैट्स व्हाई वी आर यूजिंग डेल्टा और डी। सो इट्स अप टू यू नाउ कि चाहे आप जो है वो डिफरेंस को जो है वो मीन दोनों ग्रुप्स को सेपरेट सेपरेट करते हुए पेयर टी टेस्ट अप्लाई कर लो, या आप उन दोनों वेरिएबल्स का डिफरेंस पहले कैलकुलेट करो एंड देन यू कैन अप्लाई द पेयर टी टेस्ट। ओके, लाइक फॉर एग्जांपल, जैसे मैं एग्जांपल यहाँ पे ले रहा हूँ, दैट इज रेस्टिंग हार्ट रेट। सो हमने क्या किया है कि ये हमने एक रनिंग प्रोग्राम जो है वो लॉन्च किया। सो एक साइकोलॉजिस्ट जो है वो देखना चाह रहा है कि रनिंग प्रोग्राम का हार्ट रेट की रेस्टिंग के ऊपर जो है वो क्या इफेक्ट आ रहा है, सो बिफोर एंड आफ्टर द रनिंग प्रोग्राम। ठीक है, सो अगर वो रनिंग प्रोग्राम उसने नहीं स्टार्ट किया हुआ और वो रन करता है तो उसका हार्ट रेट जो है वो कितनी देर में रेस्टिंग कंडीशन में आता है, और जबकि आफ्टर द रनिंग प्रोग्राम उसके बाद जो है उसका जो हार्ट रेट है उसका रेस्टिंग टाइम कितना आपके पास आ रहा है। ठीक है जी, सो हमने बेसिकली ये देखना है इन द एंड इस टेस्ट के अकॉर्डिंगली, बिकॉज राइट नाउ वी आर टॉकिंग अबाउट बिफोर एंड आफ्टर, दैट मीन हम सेम पॉपुलेशन से जो है वो हमने डाटा दूसरी दफा लिया, पहले रनिंग प्रोग्राम स्टार्ट होने से पहले, फिर रनिंग प्रोग्राम स्टार्ट होने के बाद। ओके, टू चेक कि हमारे पास ये जो रनिंग प्रोग्राम है वो इफेक्टिव है टू स्टेबलाइज द हार्ट रेट और नॉट। ओके, सो उसका जो डाटा हमारे पास है दैट इज अवेलेबल इन रेस्टिंग द हार्ट रेट। सो आई एम गोइंग टू use this data set which is resting high rate. So मैंने already data जो है उसके अंदर रखा हुआ है, so ये files जो है वो आप लोगों के पास available है. Okay, so data जो हमें given है which is before and after. Okay, again एक चीज याद रखिएगा कि यहाँ पे हमने इसका जो है वो डिफरेंस भी निकाला हुआ है, so x minus y करके. So peer t-test हम दो तरीकों से अप्लाई कर सकते हैं. First of all, we can use only before and after data. Okay, so if I'm using before and after data, so how we can apply? We can go to stat basic statistics paired t-test. Okay, okay, remember that before applying paired t-test, you need to check the normality, because we already have seen that how to apply the normality. So right now I'm assuming that the data is normal. Okay, and we have entered the data, both the data in separate columns. So before in sample 1 and after in sample 2, and we have the options, that is the difference is 0, that means nu d is equal to 0, and it's a two-tailed test. In graph I am clicking box plot, press OK and press OK. Okay, so in pair t-test, how we can interpret is the p-value is less than, so we will again say do not accept h0, mean reject h0. So that means the running program is before and after the resting of heart rate is not equal, is not same. So that means the running program definitely have some impact. Okay, so is it a positive impact or is it a negative impact? If you can see that the average of before resting rate was 74.5 and after is 72. So earlier it will take longer time, or you can say longer longer time in order to recover the heart rate, but after it is doing quickly. So that means we can say that the running program is effective, effectively working in order to resting the heart rate. Is it clear? Okay, so in till now, what we have discussed, we have discussed one sample Z test in, as well as one sample T test in the previous lectures, as well as we have tested the pair T test as well as two sample independent T test. Okay, so I hope ये आप लोगों को clear है. In हम जो है वो next video के अंदर जाके देख रहे हैं इनके non parametric test. That means कि अगर डेटा जो है वो नॉर्मली डिस्ट्रीब्यूटेड नहीं है तो हमारे पास वन सैंपल जी और वन सैंपल टी टेस्ट के अगेंस्ट नॉन पैरामीट्रिक कौन सा है, एंड सेकंड जो है वो पेयर टी टेस्ट के अगेंस्ट नॉन पैरामीट्रिक कौन सा, और टू सैंपल इंडिपेंडेंट टी टेस्ट के अगेंस्ट नॉन पैरामीट्रिक कौन सा है, एज वेल एज हम उनको अप्लाई करके देखते हैं. सो अभी ये मीटिंग एंड हो रही है, सो काइंडली जो है वो दोबारा सेम आईडी से जो है वो लॉग इन कर लीजिएगा. ओके ओके, अगर कोई क्वेश्चन पूछना चाहें तो आप पूछ सकते हो. ओके, सो नेक्स्ट मीटिंग के अंदर हम करते हैं, काइंडली दोबारा लॉग इन कीजिएगा.